Hello everyone, welcome back to the design of machine element tutorial. Today we'll solve some of the problems from the design of riveting. Fine, so let us get started. I will read out the problem. Two plates 10 mm thick. Okay, there are two plates are there which is having the thickness of 10 mm, that is T is given, are joined by the double riveted lap joint. Okay, the pitch of the each row of the rivet is 50 mm. Pitch is given. The rivets are 20 mm diameter, that is the diameter of the rivet, small d is given. And permissible stresses are tau, that is shear stress as 70 megapascal. Sigma c, which is nothing but the crushing stress, 160 megapascal. Sigma t is tensile stress, that is 100 megapascal. Now we have to calculate the maximum tensile force on the joint and also the efficiency of the joints. Okay, so first thing what you have to do is just write down the given data, read the problem and figure out what is given in the problem. Okay, so this is what the mention in the problem. T, that is the thickness, is given as 10 mm, diameter of the rivet is 20 mm, P is nothing but pitch, that is 50 mm, shear stress is 70 mm, crushing stress is 160 megapascal, and sigma T, that is the tensile stress, as 100 megapascal. Okay, now maximum tensile force on the joint. Okay, so how to calculate? Go for the calculation of the shearing strength of the rivet. Okay, so what is the formula for that? PS is nothing but the shear stress. Okay, the formula is 2 into tau pi by 4 into d square. Okay, now this 2 indicates that these are the double riveted joint. If it is a single riveted, then this instead of 2 1 we have to write. Remember that. Okay, next go on substitution. 2 as it is, value of tau, that is shear stress, is how much? 70 megapascal. Pi by 4, d is how much? Diameter of the rivet, that is 20 mm. Okay, once you substitute, you'll find the answer as 43982 Newton, or if you want to write in a kilonewton, divided by 1000, you will get 43.9 kilonewton. Okay, next, now we'll calculate the crushing strength. Okay, now it is PC, that is the crushing strength. 2 as it is a double riveted. Sigma c, that is crushing stress. T is the thickness of the plate and d is the diameter of the rivet. Okay, now go on substitution, putting 2 as it is. Okay, sigma c, that is crushing stress, 160 megapascal or Newton per mm. T is 10 mm and d is 20. So once you solve it, you will get PC, that is the crushing strength, as 64,000 Newton, or if you convert it into kilonewton, it is 64 kilonewton. Now similarly, we go for the calculating the tearing strength, and the formula for that is sigma T into P minus D into T, where P is the pitch, that is the distance between the two rivets. D is the diameter of the rivet and T is the thickness. So PT equal to, substitute sigma T, that is the tensile strength, 50 is the pitch, 20 is the diameter and T is the thickness. So this is the value of the tensile strength of the rivet, that is 30 kilonewton or 30,000 Newton. Okay, next what you have to calculate? We have to calculate the efficiency. Okay, we'll move further now. Now to calculate the efficiency, we have to take the minimum out of PS, PC and PT. Okay, so just go here and check which is the minimum. One is 30, one is 64 and another is how much it is? Another is 43. Okay, so 30 is the minimum so 30 kilonewton. Okay, now efficiency of the joint, we also know that the strength of the solid plate. See, if you want to calculate the efficiency, you are required the minimum of ps, pc, pt and the strength of the solid plate. So let us calculate the strength of the solid plate, which is given by sigma t into t into p. Okay, that is 100 into 10 into 50. So this is the 50,000 newton or 50 kilonewton is the strength of the solid plate. So just what we have to do now, we have to just divide these numbers, that is strength of the joint, which is nothing but the strength of the joint is nothing but minimum of this. So 30 kilonewton is minimum. Okay, and strength of the solid plate is this. So just substitute into 100. Of course we are calculating in terms of percentage. So it is a 60% is the efficiency of the riveted joint. This is how we can solve the problems on the rivet joints. Okay, thank you.